before I start, I'd like to ask our Madam Chair, we are running late on time. Would you like me to finish at 3:15?
If you can.
Okay, I will try that. Thank you. So, 5 minutes less, and people could go early for afternoon tea. So, what is the place for cognitive radio? I mean place in the frequency spectrum, not a place in the bookshelf. Well, many luminaries have spoken about cognitive radio. Chris Breyer did not say to make a presentation on cognitive radio. She simply asked for a seminar on future wireless technologies, and it's nice to see that many people have spoken on cognitive radio. So I don't need to dwell on this slide, but there are some interesting things here though. The present regime around the world is called command and control regime. What is the command and control regime? It divides the spectrum into blocks. And then these blocks are to be used for given applications, fixed mobile broadcasting. And these are specified in the radio regulations. And then if you are successful in getting one particular block of spectrum in your country, then it is hands off for other applications and other users. It's exclusive use. So this kind of allocation of spectrum creates this sort of artificial scarcity. So in this diagram, at time t is equal to t1, service A is using the block A, and at time t is equal to t2, service A uses part of the block A, but the remaining part is not available for other use. Well, how do we do it in New Zealand? Well, we are obliged to follow the radio regulations. They have a treaty level status, so we do that. And then we sell the spectrum in the form of this property rights regime called management rights. So spectrum is like land. And there are different types of management rights. I think Chris has spoken about these, so my listing here probably is not accurate, and I apologize for that. But the message is that there are these management rights, license rights, general user licenses, etc. We have in New Zealand a mixture of command and control, but within the command and control, we also have service and technology neutrality. Effectively, whatever you like approach. What's this got to do with cognitive radio? Please bear with me for a minute. So, but this service and technology neutral approach has some problems. In other words, spectrum which is allocated for mobile, well, people can use it whatever they want to, but we have a situation in New Zealand where downlinks are allocated adjacent to uplinks. So we have a base station transmitter which is a downlink talking to a mobile receiver. It is in adjacent band or band adjacent to the adjacent band to an uplink. So this is going to create interference situations. So if you have a cognitive radio in a spectrum so-called white space, and you do not make the uplink downlink sense with the existing primary allocation in the adjacent band, you're going to cause a problem, or you will be a recipient of a problem. We have another situation. This is the 2.6 GHz band, where the Ministry auctioned this 2.6 GHz band and partitioned it into lots of FDD and TDD. So we have different owners of the TDD bands. And TDD stands for time division duplex. So owner A buys TDD equipment from manufacturer A, owner B of TDD buys equipment from manufacturer B, which are not time synchronized. So block A may be in uplink mode, block B may be in downlink mode at the same time. Also they are TDD adjacent to FDD. And to my knowledge, TDD and FDD in adjacent bands do not work. These problems will arise when there are deployments of cognitive radio. So we have experienced in New Zealand, but 2.6 gigahertz band is not that well used as yet. So the time for experiencing these interference problems in the 2.6 gigahertz band is yet to come. So whether it's a primary user, PU, or CR, cognitive radio user, handling of interference is crucial. And I think this in the morning we have had at least two speeches on interference from a lady from Auckland University and Finan from Canterbury. But this gives you a slightly more different perspective of the interference. Namely, what are the various sources of interference? Whether you're a cognitive radio user or a primary user, you need to encompass. Well, transmitters have out-of-band emissions falling into a receive band. And transmitters, even if they are very well linearly designed, as we heard from the previous talk, they are allowed to emit out-of-band and spurious domain emissions. And these out-of-band and spurious domain emissions may or may not cause a problem to the guy next door. There may be intermodulation products. There could be two cognitive radios. So working on a frequency A and a frequency B, so there could be two A minus B products landing into a primary band. So you found a spectrum hole, the two cognitive radios working in hole A and hole B, and two A minus B lands into an adjacent band of a primary receiver. Or the question asked by Peter Lake this morning was a very good question. You have found a spectrum hole in an adjacent band to a TV transmitter. Television transmitters are of the orders of 200 kilowatts plus. They have large out-of-band signals which could come in adjacent bands. And that will desensitize these poor cognitive radios. They will just go mute. So this diagram, I have redrawn and simplified. This diagram was presented by Linda Doyle at the Crown Com 209 proceedings. So we have in the top here the transmitter which has legitimate out-of-band and spurious domain emissions. So if a cognitive radio is in the adjacent band, it will be experiencing a rise in its noise flow or interference from this primary transmitter. And this interference is called channel interference. You can't do anything about it. Or the other example I've shown is a very high power TV transmitter which is located many adjacent channels away, but its presence is felt by the cognitive radio which could be desensitized. So these are practical problems. So I just want to show you some real measurements. This is a 10 megahertz wide LTE transmitter in a LTE handset. And you can see the receiver may be located 30 megahertz away, or the receiver may be located 58 megahertz away. The transmitter is causing interference to its own receiver, and the receiver has to live with this interference.